What's going on, everybody? It's Mr. Gustin. We're doing chemistry today. Today we're talking average atomic mass. And you're thinking to yourself, what do you mean average atomic mass? What I mean is this. We've been discussing isotopes and that how the periodic table shows us the masses of different atoms, but those masses aren't whole numbers. And we've been discussing that these masses are, these atoms are made of protons, neutrons, and electrons. And in chemistry, in basic chemistry, we say electrons have no mass, protons have a mass of 1 AMU, and neutrons have a mass of 1 AMU. So if you're asking yourself, how do these isotopes or these chemicals, these atoms, have these decimal-based masses, it doesn't make sense because they're whole numbers. Well, average atomic mass is how we can explain that. We've got all these isotopes, and these isotopes live in varying abundances, and so we have different isotopes, and we can take their relative masses based on their abundance and the mass of the isotope and find the average atomic mass that we read on the periodic table. So, in the slides, we've got a couple practice problems. And we have our equations. So let's go ahead and walk through a couple of these problems and see some different things that we can do here to support ourselves. So problem number one, I've got three isotopes of magnesium. I have magnesium 24, 25, and 26. And we name these isotopes based on their atomic mass. So magnesium 24 is basically telling you, hey, I'm magnesium and my mass is 24. Now, is it 24? It's not. It's 23.985, but that's close enough. We call it magnesium 24. Let's find out the average atomic mass of magnesium. My equation for average atomic mass is the mass of the isotope multiplied by its percent abundance. We take the sum of all isotopes and divide it by 100 to find the mass itself. Let's go ahead and see what this looks like. Out of my data table, let's go ahead and take magnesium 24 and find its average, its weighted average. So it's got a mass of 23.985 AMU. Its abundance is 78.70%. That's the first isotope. Let's add it to the next isotope, which is magnesium 25. We'll take its mass, 24.985, multiplied by 10.13%. That's its relative abundance and relative atomic mass. Lastly, we've got magnesium 26. We'll take its mass, 25.983, and multiply it by its relative abundance, which is 11.17%. This is all the information from my table added up. We'll take this entire thing, divide it by 100, and the answer here is going to be our average atomic mass for magnesium. This is where the calculator comes into play. What I'm going to do in my calculator is type in the entire numerator, hit enter, and then do an answer divided by 100. You do it at home. You can pause and skip ahead, whatever you got to do, but you do it right now, all right? 23.985 multiplied by 78.7. That is added to the next isotope, 24.985 times 10.13. Last isotope is 25.983. 11.17 is its abundance. I get an answer, and I want to divide it by 100. Now, before I show you this answer, I want you to think, if this is the average atomic mass, and I have three options, the atomic mass is either 24, 25, or 26. You can guess in your head what that average mass could be. It's probably somewhere between 24 and 25. So when you get your answer out, if it's not between 24 and 26, you know you're way off. Now, I can even go one step further and say, I don't even think it's near 26 because the most common isotope is magnesium 24. Nearly 80% of all magnesium atoms have a mass of 23.985. This answer had better be not just between 24 and 26, it had better be even closer to 24. When I type it in my calculator, I end up with 24.31. 24.31 atomic mass units as my average atomic mass. Does that check out? Is it between 24 and 26? You betcha. Is it closer to 24? You betcha. This totally checks out. This answer makes really good sense, and I've done so using my equation. I made sure to divide by 100. Again, the whole numerator in the calculator, hit enter, and then divide it by 100, 24.31 AMU. That's my average atomic mass. That's practice problem number 1. A different practice problem we'll see sometimes is I do not give you a relative isotopic mass. Instead, I give you an average atomic mass, and I ask you to find what does that isotope weigh. And so in this case, we have magnesium again. We have the same percent abundances. We have the same masses. And I want you to find what do you think the relative isotopic mass of magnesium 26 is. Let's go ahead and set up our equation and see what we've got. The first thing I'm told is I know the average atomic mass to be 24.31. That's interesting. So 24.31 AMU is my answer. But that's equal to all the isotopes' average masses added together divided by 100. So let's look. Magnesium 24 has a mass of 23.99 AMU. 78.7% is its abundance. This is magnesium 24 that we're accounting for right now. Then we have magnesium 25. And that's mass is 24.99 AMU. Its abundance is 10.13%. And lastly, we have an unknown. We have X. We have an unknown mass. We don't know the mass of this thing, but it is multiplied by its abundance of 11.17%. This is magnesium 26. The whole thing, again, is divided by 100. And so now I have to go ahead and solve for X, which is buried in this right here. The first thing I'm going to do is multiply both sides by 100 to get rid of it. So I multiply both sides by 100. This goes away, this goes away. I'm left with 2,431 something is equal to 23.99, 78.7 plus 24.99, 10.13. plus X, which is what I'm looking for, 11.17. So now I'm left with this pretty straightforward answer, or this pretty straightforward algebraic expression. I'm just going to evaluate both of these. I'll subtract over here, and eventually I'll divide by this. This is just algebra steps, and if you're confused on this, you've got to come ask me, and we've got to get some algebra help. But what I end up, and hopefully you end up getting, when you do all of this, is somewhere around 25.95. But let's double check my math. 2, 4, 3, 1, minus 78.7, minus 24.99, 10.13. equals this, divided by 11.17 equals, perfect. I get 25.95. 25.95 AMU. Is that answer really close to 26, which is the isotope? It is. It's almost exactly 26, so 25.95 makes sense here. There are two kinds of questions I can ask you when it comes to average atomic mass. Number one, I can ask you to find average atomic mass from data. Practice problem 1. The other thing I can ask you to do is to find the relative isotopic mass, meaning for a specific isotope, what is its mass? And that's practice problem 2. Two kinds of math questions when it comes to average atomic mass. We just did some practice. There's more practice in your notes. If you've got questions, you drop in the comments, you send me an email, you ask me in class, folks. Until next time, see ya!